Again, it's a rich thing.
What is going on, guys? Welcome back to the C programming tutorial series for beginners. In today's video, we're going to talk about arrays. So let us get right into it. Alright, so let us talk about arrays. What an array fundamentally is a collection of values of the same data type. At least in C, it's the same data type because it's statically typed. In Python, we have lists, and a list in Python can contain multiple different data types. In C, we have only one data type allowed per array. So if we have an array, we can say we have an integer array, we have a character array, we have an array of arrays. Doesn't really matter, but we cannot have an array of integers, strings, characters, booleans, and so on. We have to choose one data type. And what an array essentially is just a block of memory reserved for multiple values. So we can say, for example, this here is an array. We have a couple of slots here. So we have 1 slot, 2 slots, 3 slots, 4 slots, 5 slots, 6 slots, 7 slots. So 1, 2, 3, 4, 5, 6, 7. There you go. This would be an integer array of size 7, for example. So it would be int and then square brackets 7. This is the C notation here. And essentially, since we have integers, and on my system with this compiler, an integer has 4 bytes, one such slot occupies 4 bytes, which means that 4 times 7 is 28. This whole thing here will have 28 bytes. And essentially, in all of these slots, we have now integer values. So for example, we can say we have a 4 here, we have another 4 here, we have an 8 here, a 1 here, a 2 here, a 66 here, and a -4 here. For example, those are just some integer values that are at these individual positions. Now, in programming, for those of you who are new to programming, we don't start counting with 1, we start counting with 0. So if you want to access a certain element of that array, so for example, you want to say, give me the 5th element of this array. You don't say, give me the element at index 5. You say, give me the element at index 4. Why? Because when we count, we say, okay, this is position 0, this is 1, this is 2, this is 3, this is 4, 5, 6. So essentially, when you say you want to have the position 4, you actually want to say you want to have the position or the index 3, because that is the 4th element here of the list. And this is index number 3, because we start counting at 0. Just some basic knowledge here. So let's stop the drawing here. Let's go into the code. What we essentially want to do here is we want to create a simple integer array. How do we do that? We say int, and then, for example, my array. You can call it whatever you want, and then we use square brackets. And these square brackets are now the thing that indicates that this is an array. Now, we can initialize or define an array in multiple different ways. First of all, we can just define the size here right away. We can say, okay, int my array of size 10, for example, semicolon. This creates an integer array with 10 slots. We can also say, however, that we just want to have an integer array and we want to define it right away by using these curly brackets here. This, of course, forces us to use already some default values. So, for example, 10, 20, 30, 40, whatever. And now this would automatically result in an array of size 4. So we can go ahead and say print, or actually, we can say for int I equals 0, I being less than 4, I plus plus. This is how we iterate through arrays. We can now go ahead and print the individual positions. So now we have this array, and if we want to access a certain position in that array, for example, to print a value that's behind that position or on that position, we need to pass the index. So we would say printf, and what we want to get is the integer at a certain position. And what we pass here is my array. And in the square brackets, we pass the index. Now, in this case, we're going to pass I because we have a loop and I changes. If I want to have one specific position, for example, the first position, index 0, I just pass 0. If I want to have the 20, I pass 1. If I want to have the 30, I pass 2, and so on. But since I'm in a loop here, I can pass I, and I'm going to get all of those. So I can now go ahead and compile. And you can see that we get the individual elements. Now, one thing about C that is quite dangerous, we don't have usually in more modern programming languages like Java, Python, and so on, we can go out of bounds. So we're not going to talk about, as I said, we're not going to talk about memory and pointers yet, because this is a topic for the pointer video. But essentially, you can think of it like that. Let me just turn on the drawing mode again. If you have an array with, let's say, 4 slots here, and this is an integer array, you have 16 bytes reserved for this. And when you now say, okay, give me the position 0 of this array, you get this position. With 1, you get this position. With 2, you get this position. With 3, you get this position. Now, if you're in Java, for example, and you now try to access the position 4, what Java is going to tell you is that, hey, there is no position 4. The array is already, you're going out of bounds. The array only has 4 elements and you're trying to get the 5th one. In C, this is not the case. What happens in C is that you just get this element here. Now, what is this element? We have no clue. This is neighboring memory space. You are going into neighboring memory space, and you can also go to 5, into 6, and so on, until, of course, the program crashes because you go into some space that doesn't exist anymore or is not reserved for your program. But you essentially go out of bounds, and you can go on and, see what's there. You can also set the values. And if you allow this to happen for user input, the user can, of course, cause a buffer overflow and inject some code, overwrite some return addresses, and so on. But essentially, you can go out of bounds. This is the difference between C, Java, Python, and so on. In C, you can just go over the bounds and nothing's going to happen to you. So I can change this here to not 4, but 10. And even though I only have 4 values, it's still going to be able to print whatever is in the neighboring memory space. And you can see here that I have some values. These are just the default values that are there, so it doesn't really matter. It's undefined. You don't know what's there. These are just default values that are that were there initially. So I didn't set them. Maybe no one set them. These are just in the RAM because they were not overwritten with zeros. In fact, when I go ahead and create an array, for example, of size 5, by default, I'm also going to have some values in the first 5 positions. So even though they're part of the array, so even though I'm not going into forbidden memory space with the first 5 positions, I'm still going to have some values here because those are just the default values that are there before I do something. If I want to overwrite all of those with zeros, what I do is I say equals and then curly brackets, because this is going to initialize all of them with 0. You can see the first 5 elements here are zeros, and then we go out of bounds again. And we can not only read out of bounds, we can actually write something. So we can actually go ahead and say, for example, that I want to say my array I equals something. For example, let's go I times 10. And you can see in this case that stack smashing was detected. So this is a security mechanism in the compiler, a more advanced topic that we maybe talk about in a more advanced series. We can actually turn that off if we set some specific compiler tags. I'm not going to do it right now, but you can see that I tried to write into neighboring memory space and it didn't succeed because the program noticed the problem. However, I can show you how this works in a different way. We're going to say other array. Let's say this array has 10 elements, and we're going to initialize it empty as well. Now what happens here is, in this case, I can do it. However, let me show you one thing. After I set all of these positions here, what I can do is I can say for int I equals 0, I being less than 5, I plus plus. I can print the content of the my array. So printf %d \n my array I. Like that. Now I can copy that, and I can do the same thing for the other array, but with 10. And what you can see right now is that I print the first positions here of my array. So I initialized it with 0, then we have 0, 10, 20, 30, 40, which is obviously a result of this calculation here. And then what I do is I just print other array, which I initialized with zeros, but you can see here that I have 80, 90, and then a couple of zeros. So if I actually increase this number here to 20, for example, or actually then I'm going to get stack smashing again. Let's go with 15. You can see that I have values inside of other array that I never wrote into other array. Why? Because other array is defined after my array, even though it doesn't have to be the case that they're neighboring then. But what happens is I write over the bounds of my array and I go into neighboring memory space and I write into other array. So this is something that you have to consider in C. This might seem quite abstract and complex because in Python, when we talk about lists and collections, we basically say, okay, we have a list, you can index it, don't go out of bounds, otherwise Python is going to give you an error. In C, you can really mess up stuff by just writing into neighboring memory space. And especially if you allow that, if you allow the user to do that using user input, you make your application very vulnerable to buffer overflow attacks. So that's quite simple, or actually not quite simple, this is quite interesting. What we can also do is, of course, we can pass arrays to functions. So we can say, let's define a function print underscore array. And what we want to do is we want to print an array, an integer array, for example. Now, the important thing here is that in C, you cannot use a length function. You don't have a function that tells you, okay, what's the size of this array? You have to calculate it yourself or you have to pass it. So for example, what we can do is we can pass a size as well. And then I can copy that down here and I can implement the function. And essentially what I want to do here is I want to say for int I equals 0, I being less than size, I plus plus. And then printf %d \n and the array I, like that. And of course, now if I have an array, for example, int my array again, with the default values 1, 2, 3, 4, 5. What I can do now is I can say print array, my array, and the size is 5. And you can see this works. However, sometimes maybe you don't want to know the size manually. Sometimes the size might change. So how can you calculate the size? It has to do with the size-of operator, but the size-of operator, as we already talked about, is an operator, or a function actually. I'm not sure if it's a function or an operator. I think it's a function. The size-of function essentially gives you the amount of bytes that a certain thing occupies in the memory. So for example, if I don't print the array, or after I print the array, I want to print the size of the array, I'm not going to get the amount of elements, I'm going to get the amount of bytes. So if I say my array, or actually size of course it's a function by the way, size of my array, you can see that 20 is the result. However, 20 is not the amount of elements I have here. So you have to think about it that way. If size of gives you the amount of bytes that the full array occupies, and you know the amount of bytes that a single element occupies, you can just divide. So you can say, for example, size of my array divided by size of my array 0. So the first element. Because in C, as we know, each element has the same data type. So if the element at position 1 has or 0 has a certain size, then all the other elements are going to have the same size. So if I take the size of the full array divided by the size of a single element, I get the amount of elements. As you can see, 5. So actually I can also change this here to just be the array. And inside of the array, I'm going to define the variable size, and size is going to be size of array divided by size of array 0. What's the problem now? We'll return the size of the pointer, not of the size of the array itself. Oh, doesn't this work like that? Not sure. Let's see. Actually, No, it doesn't work. Okay, because as it says, this is going to return actually the size of the pointer that we pass here, because we're not passing the element itself. Okay, so maybe it's not as simple as I thought, so maybe we should do it like that. But essentially, this is still how you can calculate it. You take the array, the size of the array, and then you divide it by the size of a single element. You can also pass just an arbitrary integer here if you know that the array is an integer. But this is how you can calculate the length of an array in C. So let's see if I have something else on the list here. Yeah, one thing that I would also like to talk about is multidimensional arrays. So we can also define, just want to mention this briefly, we can define arrays of arrays. So for example, matrices, we can say int my multi-array is essentially 2 times 3, for example, and then this essentially is the same as arrays inside of arrays. So we have 2 arrays with 3 values each, 2, 3, 4, 1, 5, 7, I don't know, whatever. And then we can iterate through that. So we can actually say for int I equals 0, I being less than 2 in this case, I plus plus. And then inside of that, we're going to say for int j equals 0, j being less than 3, j plus plus. And then we can just print all the values, printf %d \n, my multi-array, I, j. There you go. So this is how we can do that. So one last thing that I would like to talk about is strings, because I think I already mentioned that strings are arrays of characters. So in C, we don't have a string data type, we don't have string S, but we have character as array, for example. So if I have my name, for example, with 20 slots, I can say this is neural 9. This is how we initialize strings in C. However, strings are a little bit more complicated, or character arrays are a little bit more complicated, because I can't do it like that when I'm initializing it. I cannot go ahead now and say my name equals something. It doesn't work because this is not how you do it in C. You would have to use string copy and so on. This is a topic for a string video. Today we're not going to talk about strings in detail. But essentially what you can do is you can now go ahead and say printf %s \n my name, like that. And this gives us neural 9 as a result here. Now, what we can also do is we can still use this as a character array. So I can change this to character, and I can now print a specific character, for example, 2. And then we get the U here since it's position 3, index 2. Now we can do a couple of more interesting things. I'm going to show you that when we get to pointers, because we can then also see how character arrays are nothing else but just or when you treat them as strings when printing, you can also specify individual positions, and they're going to be treated as the starting position. We're going to talk about that when we get to pointers. One thing that I would like to show you here for some more understanding is that if I don't specify the size of the character array, it's going to be determined automatically. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 characters. And the interesting thing is that, for example, if I say integer array my numbers, and I initialize this with 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, for example. So we have 10 values here. We can see something interesting. If I go here and I print ld \n size of my numbers first, of the number integer array, and I do the same thing then for the my name, so for the character array, we're going to see some interesting difference here. So first of all, of course, we need to divide this by size of, let's just say 0. 0 is an integer. I hope so. There you go. We don't have to divide this by size of character because character is already 1 byte in this case, so 11 bytes is actually accurate. But you're actually seeing that if I have this integer array here with 10 elements, I have 10 slots. Whereas if I define a string with 10 characters, I get 11 slots. Now, why is that the case? It's the case because in C, in order to see that a certain string is coming to an end, we have a so-called null terminator. So what's actually stored in this array now here, if it's automatically generated, of course, if I say 10, it's not going to happen. So actually we can see what happens if I do that. Then it just works. But if I let it choose that automatically, it's going to result in 11. And the reason for that is because what we actually have here, maybe let me turn on the drawing mode again. What we actually have here is if we have, for example, ABC instead of neural 9. What we actually have is we have A, B, C, and what we have here is a null terminator. So \x00 as a byte here. This thing indicates that the string is now terminated. It's coming to an end. So for example, if I call a printf %s on this, what you're going to see is that it's going to read that, it's going to read that, it's going to read that, and then it's going to stop reading this. Because the function in and of itself doesn't know how long the array goes, right? I can also have a couple of things here. If I have a null terminator here and the array is actually consisting of D, E, F, and so on, after that, it's still going to only read these 3 characters because the null terminator basically says that, I hope actually I'm not blocking this here with my camera. I don't know. But still, this basically means that a null terminator says stop reading. And the problem is, I'm not sure if we're going to see the effect here, but if I say this is 10, and I now printf %s \n of my name. I'm not sure if we're going to see the problem here. No, actually, we don't see it right now. But essentially, this would mean that if we don't have a null terminator, it's just going to continue reading into the memory space, into the neighboring memory space. Now, maybe we can see it if I define another one here. There you go. So you can see here that if I specify a length of 10 and I fill all these 10 slots up with characters, we don't have a null terminator. So it doesn't know that the string is coming to an end, and it just continues reading and reading and reading. And in this case, probably we have a null terminator here automatically or something, or maybe we don't have one. But it continues to read into neighboring memory space, as you can see. So this is a problem. This is why when we automatically generate this, so if we don't specify a size here, this won't happen because it's automatically going to add the null terminator. So that's it for today's video. Hope you enjoyed it. I hope you learned something. If so, let me know by hitting the like button and leaving a comment in the comment section down below. And of course, don't forget to subscribe to this channel and hit the notification bell to not miss a single future video for free. Other than that, thank you very much for watching. See you in the next video, and bye.